All right, so anyway, folks, time for a Mars update with my fancy lettering. The Curiosity rover turned 10. It's crazy thinking that it actually landed 10 years ago on August 5th, 2021, 2012, 2021. It's 2022 now. In 2012, came in with the crazy sky crane maneuver, landed in Gale Crater, and has been doing some awesome science. So let's step through some of this. The Mars Science Laboratory is really the name of the mission. Curiosity is the name of the rover. And stats are over 3,540 sols, which that's a Martian day, on the surface, and it's driven more than 17 miles on those tore up, bashed around wheels, that it's still driving on them. You can see the path that it's taken, at least part of it, going up to Mount Sharp. It is now finally going up the actual mountain that's in the center of the crater, but it did cross Vera Rubin Ridge, which I just really like, and it took that long detour around that those sand dunes to make sure it didn't get stuck in the sand dunes. Now, what has it been finding out? Let's take a look here. So highlights, first of all, evidence of persistent liquid water. Well, that's what it was sent there to find out. Was there water on the surface, and was this an environment that might have been habitable for life? Could life have lived there? And one of the things you need is liquid water. And indeed, right off the bat, it saw evidence for a stream bed. The stream bed, the water was probably, about ankle deep, and it was flowing just a few miles per hour. So it was going rather slowly, drifting along, but it was persistent. It was long enough to leave behind the pebbles that you'd see in the bottom of a stream that had been there a long time. So persistent water, one of those resources that life needs to get going. It also saw evidence for the schnapps atoms. So it's a little bit of a joke with people that study life and astrobiology to call what does life need? It needs schnapps. Well, that stands for carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And indeed, it saw all of those. And it also saw organic carbon. Well, organic molecules are carbon molecules that are in these long chains, and they form the amino acids and things like that we need for life. Well, where did it see them? Well, first of all, on the left, the Opportunity rover saw evidence for, I don't know why we have an arrow on our, well, that's my own arrow. Never mind. Ignore me, everybody. On the left there is our Opportunity rover image that it saw some organic compounds. And on the right, Curiosity saw a very, very similar type of rock, sampled it, took a look at it, and indeed saw this evidence for the schnapps. The schnapps atoms were right in there. And here's the drill sample where it saw the organic molecules in that rock, drilled into it, saw the schnapps chemicals and the organic molecules. And then in a separate site, this is a different drill site, obviously, it saw an interesting silicon dioxide compound that only forms at a certain temperature, at a relatively high temperature, but a lower pressure. So what was the environment like that was able to make this crystalline silicon dioxide? I don't think they've quite figured that out yet, but maybe a hot spring. Maybe the water was percolating through these rocks and it was able to leave them behind. So it was also finding some interesting things we didn't expect with this little traveling chemistry detection kit that Curiosity had. Now, Curiosity also saw seasonal methane. We had seen some hints that there was methane in the atmosphere that kind of came and went with the seasons. Indeed, Curiosity did measure that in Gale Crater. And where does it come from? Well, could it be microbes? Could it be aliens? Maybe. But it also could be water interacting with olivine rock. So could there have been water down below, deep in the cracks down in there that's still a liquid, and it creates these methane clathrate storage sites, and then as those get broken up, there's outgassing into the atmosphere. So the seasonal outgassing is caused by the movement of the rock as it heats up and cools down. Or maybe as the water down below moves around, could there be water down below there still? Maybe, we don't know, but the methane is a little bit of a mystery. We need to figure out what is it doing there and why. We don't know, but it could be microbes that are down still buried in the Martian dirt. Martian microbes. Another thing Curiosity did was it found dangerous radiation to humans. That's right, the kind of radiations that would give these astronauts big tumors. So if you're going to walk around on the surface of Mars, if you think you're going to set up a a Mars colony of some sort, well, you need to worry about the radiation coming from space because Mars does not have the magnetic field you need to protect you from it. It doesn't have a thick enough atmosphere to protect you from it. It's only about 1% as thick as Earth's atmosphere, and the magnetic field is very patchy and sticks out in weird spots and doesn't comprehensively protect you. Any sort of habitats would need to be buried underground to provide some protection for the astronauts. So when you go out and explore like this, you'd need to have a spacesuit that was resistant to what radiation was there. You'd have to track your radiation exposure as well. And in fact, there is an experiment on Perseverance that has different types of materials that are used in spacesuits. So you can see them here, everything from polycarbonates to Teflon, coated Teflon. All of these are in little patches, and Perseverance can watch these patches and measure how they're degrading in this radiation environment. So we're going to learn whether our spacesuits will even keep our astronauts protected from things like, the lack of an atmosphere on Mars, or the very little atmosphere that's there. It's, like I said, about 1% of Earth's. This is, of course, Perseverance taking a look of like, hi, little helicopter. And Chris will tell you about the helicopter here in just a little bit. But let me tell you what Percy's been doing. So now that you know what Curiosity did in the first 10 years. Well, Perseverance landed, and then they planned a route to have it go over here to get to the Delta. So let's take a look and see how close to that plan did they actually get. Well, pretty good. First, it took a detour, went the opposite direction at first because they saw some interesting terrains, sort of 3 different terrains that came together, and they thought, well, let's go hightail it over there and take a quick look first. Then they reversed, drove all the way around very quickly, and finally, Perseverance is indeed exploring the Delta. This is a picture of the Delta material that's there. A beautiful, beautiful panorama. This, of course, has been changed in colors to look like it would look on Earth. They've modified the colors such that our eyes would see the colors these rocks would have on Earth. It would be much pinker in the Martian, the true colors you'd get on Mars. A little bit more like this. This is the first sample site of Delta material. So that's a sedimentary rock that it drilled into, and it actually managed to pick up material of a rock. So you're seeing there material that was in a sedimentary rock that was laid down over time in that Delta. The Delta might have the history of life in Mars in it. Maybe there's chemicals there that the signature says this life made this stuff. We don't know. Perseverance itself does not have the ability to look at that hole that was made, although this is before they made the hole, I think, or maybe right after. It doesn't have the ability to go in there and make these measurements. You need a very big lab to get it in the details we need. So it's taking these samples and storing them. And the idea is you store it for the future and send it back to Earth, and then you make these measurements in an Earth lab. Now, this is the sample before it was drilled out. And you notice there's a weird pattern there. There's 3 holes that were put in there by the laser. They shot it with the laser 3 times that give us the orientation that rock was before they drilled it out. So they can look at the main rock around it. They can look at the sample and say, this is the long side, this is the short side. Well, if you connect the dots, that makes an L. So there were a lot of people named, that had L names of various sorts that were excited to say that L stands for me. You just did some graffiti for me on Mars, Perseverance. So anyhow, you can see these drill sites that are there and the samples that they're taking of this new Delta material. So it's very, very exciting. Now, what samples have been collected so far? 13 of the 38 sort of samples that they can do have been collected, and 2 of the 5 witness tubes. Now, what's the difference in those? I'm honestly not sure. So I'll have to look that up for you next time and bring it up. But one of them was actually atmospheric. So that was the one I think that the stuff fell out, or they made their first drill and they didn't get anything in there. So it just contains Martian atmosphere. But in a way, that's kind of good. And we'll step forward here and say the next one they did was a rock core. It ended up being an igneous rock, which means that it's lava. So this was a volcanic eruption. It wasn't sedimentary. It wasn't laid down by water over a long period of time, or laid down by winds over a long period of time that could store life. You tend not to find any fossils or evidence of life in igneous rocks, but this first one is igneous. The next one they took was an igneous rock as well. The next one they took was igneous. The next one they took, well, guess what? Igneous. The next one was another igneous rock. Are you starting to see the pattern here? The next one was a volcanic igneous rock core. And why are they taking all these igneous rocks? Well, they want to characterize the environment of where it is. So it's exploring this delta region. Yes, this used to be, all of it we think was underwater, but at the same time, lava flows came through here and they changed what was there. So we need to understand those lava flows in order to disentangle what might be a sample that could contain life from the other types of lava rocks that are around. So indeed, the next one was igneous as well, another igneous sample. Oh, wait, a sedimentary sample. So this was Swift Run, as they called it, and it was a rock core at Skinner Ridge. But this, whether this was delta material or whether this was laid down by winds, we're not really sure, because this, I don't think it's up on the delta. I don't think that was the first delta sample. The next one was also sedimentary, so exciting that this is a sedimentary rock. And then finally, another one, sedimentary on Wildcat Ridge, another one there on Wildcat Ridge. And I think it's that last one on the Wildcat Ridge that are the first true delta samples. And you can see here, 10, 11, 12, and 13, I think, are all probably going to be considered delta samples, by the way, the last four. So I misspoke earlier. Anyway, this is the location of all the samples that it's taken so far, but these samples have to get back to Earth somehow. So we're going to need a sample return mission, and you can see sort of the general idea. We have a helicopter to help scout what's going to be going on. We have Perseverance there to be able to hold on to the samples and deliver them to the lander. And then that rocket that's coming up there will have to blast off. It's a two-stage rocket that the samples will be loaded into, and it'll head back to Earth. Now, Earth is not that big in the Martian sky. It's a little tiny blue star. But anyway, you get the idea. So where's it going to land? Well, here looks pretty good. Perseverance has been scouting for a good landing spot. The idea is let's have it be free of big rocks, free of things that could be bad to land on. And indeed, this looks pretty darn good. These are some little tiny rocks here, then it's pretty broad. So if we can target this and land with any sort of accuracy with our lander here, Perseverance could get back over there and deliver the samples to be loaded onto that rocket and take them off. And they have begun working on the rocket itself. You can see right here, they're testing it. So there it comes down and crashes into the metal structure there, and the legs went down to kind of cushion it. But they're working on the lander already, and this whole thing will hopefully bring the samples back to Earth sometime in the 2030s. So we have a little while to wait to get them here, but that is the plan, to actually eventually land and make it all the way back. So Chris, I think it's time for you to tell us a little bit about what's been going on with our helicopter.